Here's our quiz review for tomorrow. Ryan, when's our quiz, honey? Tomorrow. Okay. So, there's only 8 questions. I told you that. It's very basic. I know it's shortened class periods tomorrow. It's only shortened by about 5 minutes, I believe. So, you'll have plenty of time. But again, I made it so there's only 8 questions, so you have ample time to get everything done. You're not going to use a calculator. You don't need one. If you are asked to rewrite in either logarithmic or exponential, all you're doing is moving stuff around. So in this case, like number 1, what form are we starting off in? Log. We're starting off in log. How do you know? It says log. Good. So what we think of when we start in log, the little 3 becomes big, becomes our big base. And then what happens to 7 and 2,187? They switch places. So 3 to the 7th equals 2,187. Guys, that should make sense. You should look at that and say 3 to the 7th power equals 2187. Not 3 to the 2,187th power equals 7. Right? You should be able to see that and go, oh, okay.
I'm not sure I understand.
Thanks, Siri. That was good, Evan. That was good. That was good. Well done. Do you get that, though?
Yeah.
Okay. Just perfectly timed. All right, what are we in now? We're starting off in exponential. So then we're going to go to log. So my big 7 becomes little 7. So I'm going to write log. Look, guys, the 7 is little.
To the 16. 8.
Don't write it real big next to the log, because if you wrote it like this, that's 2 totally different things. That means log base 10. So you want a little 7. Make sure it's little. I understand it's little. And then what happens with the x and the 16,807?
They switch.
They switch spots. That's it. So 16,807 equals x. That's it. All right, moving on to the next one. I'm in which form?
Log.
So I want to go to? So my little 4 becomes
Base.
big. And then what happens with x and 40?
They switch.
They switch spots. Perfect. Does that make sense? Okay, good. All right, now it says to evaluate without a calculator. Well, this is our log rules. If I have log base 4 of 4, what this is saying is 4 to what power gives me 4? 1. This just cancels out and becomes 1. What do you know about E and ln? They're what of each other? God bless you. They're inverses, opposites. So E and ln cancel out. My answer here is just how much? 12. Good. God bless you. All right. Log 12 of 12.
1.
It's just 1. Perfect. Okay, now we got to think a little bit. Log 2 of 32. I'm going to give you something that you should be able to handle. What this is saying is 2, God bless you, to what power is 32? It is 5. Good. And then here, as soon as we see a fraction,
You give up.
no, you don't give up. You don't give up. When I see a fraction here, I think negative, what? Exponent. God bless you. I think negative exponent, because watch, guys, what's another way? Well, let me evaluate it a couple different ways. Little 3 becomes big 3. So 3 to what power will give you 27? 3. I don't want 27, though. I want 1 over 27. So it's negative 3. Another way that you can look at that is, could I write 1 over 27? This is really 1 over 27 to the first power, right? If I brought the 27 up, it would be 27 to the what?
1.
To the what?
To
the negative 1, right? So if you did that, then you could see also how it become negative 3. But guys, when you see it, when you have a base that's going to become a fraction, you think negative exponent. Is that right? Okay, so now when we expand and we condense, guys, a lot of things are going on in a problem. Yesterday, Nunez did everything in one step. He said, is this okay? I said, of course. But make sure you get everything. I personally would not do everything in one step, but that's just me. I look at something, I'm going to evaluate it. I see a bunch of stuff going on. What's the first thing that you see? I see division. Good. When I see division, when I'm pulling it apart and expanding, I think of what? Subtraction. Good. What else do you guys see? I see exponents and roots. What do those become?
Numbers in the front.
Numbers in the front. Coefficients. Good. I also see multiplication here. Yes? Multiplication becomes addition. So I'm just going to rewrite this as log. Everything gets its own log. So log 7. What's another way that I can write the cube root of x? X to what power?
Third.
X to the 1/3. Okay. You guys saw division, so that's subtraction. Yes? Then I have log 7 of y to the 4th. Then what? Plus or minus? Plus
Z to
log 7 z. Is that to the 2nd? I'm asking you. That's how I like to do it. Every single thing gets its own log 7. So now, what do I do with all of these lovely exponents? What do they become? They become numbers in the front. They become coefficients. So 1/3 goes here, 4 goes here, 2 goes here. So my final answer would be 1/3 log 7x minus 4 log 7y plus 2 log 7z. Do you guys see how everything is written linearly on one flat plane? I don't have any exponents. Do you guys see that? I don't have any roots or square roots or anything like that. Everything is written all flat.
Wait, why is it log 7 of what?
Because you have a log 7 out in front. So that means every single thing is going to get a log 7.
Okay.
Like here, when I look at this problem, every little thing is going to get a what?
LN.
An ln. Okay? I'm going to erase this part so I can have some room.
So, do we have to put this in parentheses to show that everything goes
No. Because order of operations will work that out. Good question, though. All right, so everything's going to get its own ln. What do you guys see? I see a few things. I see exponents. Good. I also see a square root. What's another way I can write x plus 1 the square root of? I can write it as x plus 1 to the what?
1/2.
1/2. Okay. If you want to do that at first, you can. Again, there's no right or wrong way to do this. I mean, yeah, there is, but to work it out, just take your time. So I'm going to write ln of x squared. What's being done between x squared here and this square root of x plus 1?
Multiply.
Multiply. So when I see multiplication, I think what?
Addition.
Addition. Then I have x plus 1 to the 1/3 power. Whoops, I forgot my ln, didn't I? Everything gets its own ln, remember. So now I see exponents. What do I do with exponents?
One to the front.
I bring them out in front. So this is 2 ln of x.
Shouldn't it be 1/2 and not 1/3?
Oh yeah, I don't know why I put. I mean, I do know why I put because the last problem was, but you're right. Thank you. So then I have 1/2 ln x plus 1.
And you have to put the parentheses.
Yes, because it's that whole expression. Now, looking at on number 11, a lot of you got the concept here, but you missed one little thing. I see a cube root. When I see a cube root, I think of what fraction?
1/3.
1/3, good. And I see a over b, which makes you think of what? Subtraction, good. If I were you, I would rewrite this first like this. ln of the cube root of a over the cube root of b. Can I split it up like that?
Yeah.
Yeah. But if you don't have to, but you, in order to write this correctly, I want to make sure you guys see what's going on here. So I can say ln of a to the 1/3, right? Agreed?
Yeah.
Okay, and then I put plus or minus. Why is it minus?
It's divided.
Because it's divided ln of b to the 1/3. And then what's the last thing I do?
Bring the exponent to the front.
Perfect. So I have 1/3 ln of a minus 1/3 ln of b. Some of you, when you were coming up and asking me questions, you had only the 1/3 out in front of the a. Just understand that that cube root goes to both. It's the same thing if this was like a over b squared. Does that square go to just the a? No, it goes to the top and to the bottom. So just make sure you remember that. Nunez.
Oh.
Or are you just stretching?
No, if the A and B, the matters can be capitalized, they're not.
All right, let's go down here. Guys, look, God bless you. Sometimes it'll just say, Evan, it'll just say condense or expand. It won't tell you these ones you condense, these ones you expand. But do you see how this one looks like it's already pulled apart? You guys see that? How up here they look like they're all smushed together, right?
Yeah.
And then here they look like they're already pulled apart. So we're going to go backwards. So the first thing I would do is check, are all three of the logs the same log?
Yeah.
Log base 3, right? So that means I'm going to rewrite log base 3 out in front just one time. What do we do with coefficients? They become what? Exponents, right? Agreed? So I can rewrite this as log base 3.
X to the fifth.
I have x to the 5th. What does that mean?
Subtract.
Divide what?
Log
Square
3 of
root
y.
Y to the 1/2, which is the same as what?
Square root
Square root of y,
and then z to the 6.
times z to the 6. Do I have to write that little time sign?
No.
No, if you stick them together, that's fine. Do I have to put this in parentheses?
Yes.
Yes.
You don't have to, but you can if you want to. But it's not wrong if you don't. But do you guys see how many times did I write log 3? Just once. You just write it out in front. Yes, Ryan.
If you put x fifth over the square root of y in a parenthesis, and you have another parenthesis times that, like these things, it doesn't seem.
As long as z to the 6 is... Oh, wait. You had it like this?
Yeah, but there's like a bigger parenthesis, so there's being multiplied.
If you wrote it like that, then you would have to have a 1 over it. Because if you don't, then it looks like z to the 6 is being multiplied here. Junius.
Oh, I did mine, like, I did parentheses like that, and I put parentheses around y and z to the 6.
Like that?
Yeah.
That's fine.
But like, another one like that.
That's fine.
Okay.
Mhm.
Thank you.
All right, let's look here. Again, this was a mistake. I forgot to put an L in there, so some of you were a little confused. I understand why. My bad. First thing I'm going to do is check, are all of my logs or natural logs the same? Does everything have an ln? It's supposed to. If it doesn't, put it there. So this goes here. This goes here, right? Yes or no?
Yes.
So I'm going to write 1 ln real big out in front. Then I'm going to say 3x plus 1. What?
2.
Divided by
X minus 1.
x minus 1 squared
And then
times
the cube root of x plus 7.
the cube root of x plus 7. There you go. Very good. Now I'm going to do some more of these expanding and condensing examples, just so we have plenty to look at. How we doing?
Good.
Good? Hayden?
I have a question about number 8.
Okay.
You said, what was the answer?
Oh. The answer would be 1 over 3 log 7x minus 4 log 7y.
Oh, not that one.
Okay.
Number 8.
Number which one?
8 up top.
Oh, my bad. I'm sorry. You said 8. I just didn't look at it. Negative 3 is the answer.
Could it be 1/3 to the 1/3?
No, because that would be cube root. 27 to the 1/3 power is the cube root, so it'd be 3, but I want 1 over 27. Yeah, I see what you're saying. All right, let's look at these. I'm just going to do the ones that are highlighted. Again, if you want me to do more when I'm done, that's fine. But, guys, they're not telling me what to do here, but what am I doing? Am I expanding this? Am I pulling it apart, or am I smushing it together? You're expanding it. Good. Because it's already smushed together. What do you see is happening between x and y? Multiplication. What do we think of when we think of multiplication? Addition. So let's look. I'm going to write log of x plus log y to the 3rd. Am I done? The 3 goes where? So it's log x plus 3 log y. Yeah? Okay, good, 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 good. What else do we want to do?
Post this one too.
Excuse me?
Are you gonna be on? It's gonna be on the video.
Yeah. All right, what do you see here? A couple things.
Square root, cube root.
I see a cube root. As soon as I see cube root, I think what as an exponent?
1/3.
1/3, good. And I see a multiplication, which means what?
Addition.
Addition. So I have the natural log of x plus the natural log of e to the 1/3. Yes? Okay. What happens with 1/3?
Move to front.
It moves in the front. So I have the natural log of x plus 1/3 the natural log of e. That's an ln. What do you guys notice here?
There's an exponent inside.
There's an exponent. Good. What else do you notice?
Square root.
There's a square root. The square root is over what? Just the x? No, it's over everything. This is really written like this. X to the 4th, y to the 1/2. Agreed?
No.
Yeah.
It is?
Mm-hmm.
Wouldn't it be?
You could put it on both, or you could put it where? You could put it, when you rewrite it, you could put it out in front. Like you could go like this. You could say, breathe that 1/2 out in front. And then you could say ln of x plus ln y, right? And then what happens is 4.
Goes to front.
So it would be 1/2 ln 4 ln x plus ln of y. You could leave it like that. You could also do what with the 1/2? If you distribute it, if you put it back in, it would be, what's 4 times 1/2?
4/2.
4/2, which is 2, right? 2 ln of x plus 1/2 ln y. I would take either one of those. I'd take either one. All right, keep going, keep going, keep going. Lots of stuff going on here. What do you see first? Division. What else do you see?
Exponent.
An exponent of 4. I also see a square root, which becomes 1/2. And I see multiplication. Good. So let's just take our time. Let's write it out nice and simply. I have log of 100. When I see division, I think what?
Subtraction.
So minus. I write the word log every time. I'm going to say x to the 1/2. Right? Plus. Good. Log y to the 4th.
Move everything.
Now again, Nunez, if you want to do everything all at one time, feel free. Just makes me nervous. Yes, ma'am.
So when is it, like, when it's, you said, remember the equation where you don't separate, is it if it's like x plus 1 or x minus 2?
Correct. If it's in parentheses, like stuck together, yeah. How do we feel about this? Good. You guys are doing a really good job. Do one more. Oh, here we go. Oh, my bad. Yeah, sure. I'm sorry. Alexis, the next one, just one like you just asked.
Oh,
And then I got a couple more of, they're already expanded. We're going to smush them together, and then we're done. Because, Ryan, when's our quiz?
Wait, why is the 100 you keep
It's
it
not a
here?
YouTube video.
Why is what?
The 100,
Why is it what? Say it one more time. I'm sorry.
you keep the 100 behind the log. Why don't you put it in the front?
Because it's not an exponent.
Oh, okay.
It's just all by itself.
Oh, yeah.
Okay, look, guys. This 2, does it go to just the numerator? No, it goes to both the numerator and the denominator. So I'm going to rewrite this real quick as log of x minus 1 squared over x plus 1 squared. Just so you guys see that. So the first thing I see is a big division sign. Division means what?
Subtraction.
Okay, so it's log
X minus 1 squared.
x minus 1 squared minus log x plus 1 squared. Okay, do you see why I'm keeping x minus 1 and x plus 1 in parentheses? Because they have a plus or a minus sign in them, they're stuck together. You can't just separate them. So now I have one last thing to do. I bring my 2's where? Out in front. So it's 2 log x minus 1 minus 2 log x plus 1. This says 2. Let me just rewrite that so it doesn't look like Valentina wrote it. 2 log. Okay? Now when we move on to the next page, I'm going to do just a couple more, just some extra practice for you guys. Whoa, whoops. Look how these are set up. Are they already pulled apart? Yes, so we're going to do what? Smush them back together. The first thing you need to look for is make sure they all have the same log. Do they all have the same log?
Yes.
Yes, that means I'm going to rewrite the word log one time out in front. What's going to go on here with my 3? Becomes a what?
3.
Becomes an exponent, right? I have pluses in between everything. So what does that mean I'm doing to everything?
9
So I would write 4
times.
x cubed y. Could I write a times sign in between each of them? Yeah. Do I have to? No. Could I put them all in parentheses like this? Sure. But we all know that when you stick letters and numbers together, it just means to multiply. Do I have all the same log?
Yep.
Yep. Okay, what is this 3 going to become?
X.
What is the... Okay, that's it. So I rewrite the word log.
X cubed.
So I have x cubed, what?
Times 2.
Times 2
Divided by
divided by...
y. Divided by. I'm too big. Wait, is that right?
You guys looked at me like, wait, what?
Is that right?
If you left it like this, I would not mark off. Could I simplify this?
Yes.
I could rewrite this at the numerator as 2x cubed, right? And if we're dividing, what would I do? Keep change.
Flip.
So I could do that. You don't have to. If you left it just like that, I'm okay with that. Actually, let's just do that. I just want you guys to work on
Wait, can you go back to that last one?
the basics. Yep.
Okay.
Okay. What does 1/2 become? The exponent? Okay, do they all have the same log?
Yeah.
So I'm just going to write log base 2 out in front. Then I have what? 9 divided by...
Times x squared by 13.
Yep. I'm not giving you guys any of these crazy complex fractions, but I just want you to understand. All I'm asking you is to understand what everything means to smush it back together. You can leave it just like that. That's fine.
But there's not gonna be any quiz scenario.
Not where you have complex fractions, no.
Can you go over just one more where it's like on the review was like 3 to 27
Sure.
and how to try to figure out.
Sure.
'Cause that's one thing without complicated.
Sure. All right, how is this a little different? Don't worry about all the division and stuff like that. What I want you to see is, does everything have the same natural log? Okay, so I would put the natural log out in front. And then I would do, simplify all of this. Where does that 1/2 go?
In the back.
In the back of what?
Parentheses.
Of everything. So this would end up being a square root of all of this. Do you see how this is written with the coefficient is in parentheses, it's outside of the whole natural log itself?
Wait, do you still have to write the 1/2 if you already have the square root?
No. I'm just showing you that would become that. It's everything underneath.
Sorry. It would be 8x squared divided by 4 divided by
Mhm.
3.
X cubed.
X-
Yeah.
I mean, yeah, x cubed.
All right, let's look at this one. This one looks complicated because you have a bunch of expressions. It's really not. Do you have the same natural log on all of them?
Yeah.
Okay, so I'm going to write natural log out in front. 2 becomes the exponent here. Agreed?
Yeah.
Okay, so I have what?
X plus 3
X plus 3 squared times
x minus 3
x minus 3
divided by x
divided by x squared minus 9. They are not asking you to now factor or anything like that. All they're asking you to do is take this natural log that we have pulled apart and smush it back together. All right, Alexis. Let me think. If we had... something like that.
Yeah.
Okay. So you guys have this. What this is asking you is, remember, this is in logs. So if we went to exponential, 9 to what power gives me 1 over 81?
9. Negative 9, negative 9.
Not negative 9.
5. Oh, wait, 2.
Oh my bad, negative 2, negative 2.
Negative 2. Why is it negative?
Because it's a fraction.
Because it's a fraction. I can rewrite this as log. I know you guys are thinking 9 times 9 is 81. I could rewrite this as log 9, 81 to the negative 1. Couldn't I?
Yeah.
So when I do that, maybe that makes it seem a little easier because you think, well, 9 times what gives me 81? 2. And what is my exponent? Negative. So that's why it's negative 2, because you're making it a fraction. So here, I could rewrite this as log 2 of 32 to the negative 1. What does that mean immediately when you see a negative? It's a fraction, right? When you see a fraction, you think negative exponent. So what, 2 times what would give me positive whole number 32? 2 to what power? 2 times 2 to the 5th power? Yes? So if I don't want the whole number 32, I want 1 over 32. So that's why it becomes negative 5. Do you see that?
Okay. And then if it was like, if it had said like negative 32, then it could, you just change it to like 1 over.
Okay? Feel all right? All right, very basic quiz. I promise you tomorrow. 8 questions. Nothing tricky, not trying to throw you off at all. You're going to have to rewrite a couple, evaluate a couple, expand and condense a couple. Sound good?